Alright, so a little bit of an update. So I sort of rethought the design um, for the 1-bit register, and I realized that I overcomplicated it by a lot. So this new circuit only uses 5 gates, and I believe this is the minimum number of gates that you need. Um, but it works exactly the same. So this button on the right is the data, and then the button on the left is the write button. Um, so you can see I can toggle the data, nothing happens, the smiley face doesn't do anything. If I go ahead and enable writing, and then I write a 1, you can see the smiley face goes. If I disable writing, again, you can see nothing happens. If I enable writing again and write a 0, you can see the smiley face turns off. And we're back to the same state. So if I have writing enabled, then whatever the button is, the smiley face will be. So it's exactly the same circuit, but a lot smaller, a lot simpler, doesn't require a clock. So yeah. The other thing is this circuit here, which you could kind of see off screen, but this is basically a decoder. So the doors at the top, as well as the circuit on the right. The circuit on the right is just like a more compact version, but they're both the same thing. So what a decoder does is it takes a binary number and converts it to a single output. So for instance, if I do 1, you can see the far left door closes. 0, 1 represents 2, so you can see the second door closes. And then 1, 1 represents a 3, so you can see the third door closes. And then same thing on the right. You can see the top one lights up, middle one lights up, and then the bottom one lights up. And if you use 2 of these decoders and a whole bunch of these 1-bit registers, what you get is this guy. So each of these columns represents 8 bits. So they're basically an 8-bit register, and there's 3 of them total. You can see over here there are 2 decoders. This one is for writing data, and this one is for reading. I'll go ahead and show off. So the doors that are below me represent the data that's being read from the registers. The buttons above me represent the data that I'm writing to the registers. The 2 buttons on the right here represent which register I'm reading from. The 2 buttons on the left represent which register I'm writing to, and then the button on the left just represents go ahead and write the data. So you can see the doors on the bottom are all zeros because I'm not reading from anything. I can cycle through the registers and you can see I'm still not seeing any data because I haven't written any data yet. So I'll go ahead and select register 1. And for example, I'll just write the first 3 bits. Go ahead and write that. I will select the second register and we'll write the last 3 bits. Go ahead and write that. And just to make sure that that all worked, I'll go ahead and read register 1. You can see the first 3 bits pop up. I'll read from register 2. You can see the last 3 bits pop up. So now let's write to register 3. And you know what? Let's just do every other. Oops. Go ahead and write. I'll unselect that register and just turn all these off by default. And then I'll cycle through the registers again. So register 1 has the first 3. Register 2 has the last 3. And then register 3 has the alternating pattern. So that is a full 8-bit register file. 3 registers should be the minimum you need for basically a computer. 2 registers to read 2 inputs from, and then a third register to store the output. of say an addition operation or a multiplication operation or something like that. So 2 inputs and an output to theoretically an ALU, but obviously this is step 1. So yeah.